I'll share my screen. Okay, my screen is visible.
Yeah.
So we start with the OOPS. Okay, introduction to OOPS. One second. Yeah, introduction to OOPS. Introduction to OOPS. Okay, so OOPS. OOPS is nothing but object oriented, object oriented programming structure. Programming structure. So we can say that this is the heart of SV. Okay, so oops is the heart of SV, we can say that. Okay, so we need to know about the concepts of this oops. In this we have the concepts called class. Okay, class, and next object, and next inheritance. Okay, and next you have polymorphism. Polymorphism. Okay, and next you have handle. Okay, so we'll discuss all these things. Okay, so basically, like first we'll discuss about this class and object. Okay, class and object. What is this class? Okay, class is like it's like a blueprint. Okay, it's like a blueprint. Okay, blueprint, and it's a data type. It's a data type. Okay, so it's like a blueprint. Okay, and next object. Okay, object is nothing but it's a instance of class. Okay, this is nothing but instance of class. Instance of class. Okay, so like instantiation we already seen, no? Instantiation means what, in the test bench or in hierarchical modeling we done, like we are instantiating connection by position and connection by name in the Verilog, no? Same like that, this is the instance of the class. Okay, so how the objects are created means objects are created dynamically. Objects are created dynamically. Objects are created dynamically. Okay, so we'll see the difference between this SV and so what is the in oops the difference between SV and Verilog. Okay, what is the difference? Okay, so this is about oops. So we'll see the difference between this SV. Okay, basically what is this SV, and next you have Verilog. Okay, Verilog. So if you see the differences. Okay, so first class. Okay, class is nothing but this is a data type, or we can call it the blueprint. Okay, and in Verilog you have module. We have a module. Okay, so when the module is created, suppose like if you consider like if you create like when you write in Verilog module ABC, and here int c, we are giving int c, and next end module. Okay, so when the module is created, so module is created at t equal to 0, and this is static in nature. Okay, this is static in nature. Okay, so module is created at what? So module is created it is this is created at t equal to 0. And this stay ever. Okay, stay ever. Okay, so that means this is what static in nature. Okay, and next here in this So here we can say that in SV, so related to the class, memory is not created. We need to create the memory explicitly. Okay, so memory is not created. Okay, so memory is not created. We need to create the memory explicitly. Okay, so in SV, memory is not created. Not created. Okay, we need to create. We need to create the memory. We need to create the memory explicitly. Okay, here memory is created implicitly by default. Okay, automatically the memory is created. Okay, so when you are writing the module, memory is created at t equal to 0. Okay, memory is created implicitly. Okay, implicitly. Okay, and next, so here you have the objects. For every class you have a objects. Okay, so this is nothing but, what is this object? This is instance for the class. Instance for the class. Okay, instance for the class. Okay, and here you have module instances. Module instances. Module instances. That means we already seen, no? Suppose if you want to design full adder by using half adder, first you write the program for half adder, and you are instantiating that half adder 2 times, and you are writing for the OR gate. So you can instantiate connection by name and connection by position with order list. Okay, that we already discussed in the Verilog. Okay, and next you have the handle. Next you have the handle. What is this handle? This handle pointed to the object. Pointed to the object. Handle is pointed to the object. Okay, here you have instance name. Instance name. So that means when you are writing the instantiation connection by name or connection by position with order list, first you need to write the design name followed by the instance name. Okay, so in the Verilog you have the instance name. Okay, so this is the difference between this SV and Verilog. Is it fine?
Yeah.
Yeah, instance name means we already seen, no, like suppose the adder circuit, we already wrote the program, and after that we need to instantiate half adder. Suppose like if you wrote the program, suppose if you see, 1 second, so in the Verilog, suppose if I want to design so module instance, if you see the module instance, so first I wrote full underscore adder. Okay, after that half underscore adder. Okay, half underscore adder, instance name is ha1. Okay, and next half underscore adder ha2. Okay, this is nothing but what? Instantiation. Okay, now here when this instantiation will be created. Okay, before the instantiation only the half adder was present. Okay, this is option 1. When this will be created, okay, before the instantiation only the half adder was present. Before the instantiation only the half adder was present. And second option is after the instantiation only. Only the half adder is created. The memory allocated. Which option is correct? Can you guess? When I am writing this instantiation, which option is correct? either option 1 or option 2. Means option 1 is before the instantiation only half adder was present. Option 2 is after the instantiation only half adder is created and the memory is allocated. Which one you can guess?
Yeah, so basically the mechanism would be like creating a full adder using half adder.
Yes, yes.
So we are basically importing half adder module to the full adder and uh, yeah, allocating memory to full adders module.
Means what you are telling? You are telling option 2 or option 1?
After instantiation only, the half adder, no, it's not created, but the memory is allocated to the full adder.
Okay. But first what you are writing first before writing full adder, first you will write the code for what half adder one time, no?
Half adder, yeah.
One time. After that, in the full adder, you write the program and you are instantiating this half adder one time and second time, and you are writing for OR gate. Okay. So that means
Yeah,
from this, before instantiation only half adder was present, no?
yeah, that's it.
Before instantiation only, you are writing the program for half adder. Before the instantiation only, so half adder was present. So you are you are instantiating that half adder how many times? Two times. Okay. So this is not
Yeah,
correct option. Okay. After instantiation only, the half adder is created. This is not memory is allocated. This is not. Before that, before means before instantiation, before calling only, you are writing the program for half adder and you are calling means you are instantiating that half adder by using connection by name or connection by position. Is it fine?
yeah.
Okay. Next. So next we'll see. So here if you see the class, it will be like this. So if you see the class, yes, class, okay, let us take class ABC, okay, class ABC and some piece of code, okay, and end class, okay. So this can be so we can write outside the module or inside the module also, okay. So can be write, so class can be write outside the module, okay, outside the module, or we can write inside the or we can write inside the module, okay, inside the module, okay. This is class, okay, class, okay. So next so how it will be there? Suppose example, if you take example, class class test, okay, class test, and you have the properties, okay. So here I am writing, that means here you are writing class, so class same I am writing test, okay. So you have the properties, okay. So what are the properties? Properties means you need to declare the variables, okay. What are the variables? Properties means you need to declare int a comma b, okay. You need to declare the variables, and next you have the methods, okay. What are these methods? Methods are nothing but you need to write functions or tasks, okay. You can write functions or tasks, okay, and end class, okay. So here also end class, okay. So for the class you have the properties means what? So properties means here so properties means you need to declare the variables by using int data type, and methods means you need to you need to write functions or task in the class, okay. Is it fine?
Yeah.
Okay. So next use next so how you are writing means so see here. So for every class there is an object that is instance for the class, okay. So here if you see so class test, okay. Let us take int a comma b comma c, okay. And I'm writing function display okay. So I'm writing some lines of code, okay. And end function, okay. And end end class. Okay, so here so when I'm writing this class, no memory will be created. Okay, no memory will be created, no memory is created. Okay, so memory is created when we are writing the object, then only memory will be created. Okay, no memory will be created for the properties or methods unless we create the object. Okay, this is one of the important point. Okay, so simply you are writing the class means so no memory is created. Okay, no memory is created, no memory is created for properties, for properties or methods unless 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 we create an object for the class, we create an object for the class, unless we create an object for the class. Okay, so that means for every class you have the object. Okay, so how to create the object, I will tell you. So for every class there is an object. Okay, then only the memory is created. Simply you are writing the class and this properties and methods, so no memory is created. So for every class you need to create the object. Okay, so here I will create so I'll write with this object. So I'll write creating the object for the class or instance for the class. Okay, so creating object for the class, or we can call as instance for the class, instance for the class. Okay, so how to create the objects for the class and how to create the instance one for the class, so I'll tell you. So step one, declare the handle of the class, declare the declare a handle of the class. Okay, so declare a handle of the class. Okay, handle for the class. Okay, here some words will come like class, object, instance, handle, you need to remember. Okay, so you need to declare handle for the class. Step 2. Okay, step 2, create an object using handle, create the object using the handle, create an object. Okay, create an object. Okay, so create an object using using the handle. Okay, so create an object using an handle. Okay, so like example, suppose I am writing class test, some piece of codes are there, piece of code, and end class. Okay, after that I need to create the handle. Okay, so here I need to create the handle test t underscore h, this is nothing but handle. Okay, t underscore h, and here I need to write the object. Okay, so initial begin t underscore h, this is equal to, here you need to use new square bracket. Okay, so the normal bracket and end. Okay, so that means I'm calling, that means here this is nothing but what, this is nothing but handle. Okay, I need to create a handle for this class. Okay, and after that, so here declare a handle, this is nothing but handle. After declaring the handle, you need to create the object. Okay, so you need to create the object. Okay, create the object for this class. Okay, so this is how you are creating the handle. Okay, so we already seen some topics now. We already used this new with square brackets. Where we used, can you recall?
Sorry?
New we used.
I didn't get the question. Sorry. Can you repeat it?
See here, this is nothing but t underscore h equal to what, new with normal brackets. This is nothing but what, this is we are using in what objects. Okay, so that means this t underscore h handle equal to what, I am creating an object new. Okay, so in some concepts we used new with square bracket. In which concept we use this square bracket?
We
Can you
use them in queues and arrays. I'm not wrong.
arrays? Okay, which arrays? Arrays correct answer.
Yeah, associative arrays,
No,
dynamic arrays,
dynamic arrays.
dynamic. Yeah,
Yeah, dynamic arrays we used. Okay, so dynamic arrays, when you create a dynamic array, so we need to create with what? A new square bracket. No, there I told square bracket.
yeah,
Okay, so here that is the difference. This is nothing but in dynamic array we are using square bracket, but in the objects we are using normal bracket. Okay, that is the difference. It's fine now.
yeah.
Okay, yeah. So for every class there is a handle, and that handle, with that handle you need to create the class. Okay, so you need to create the object. Okay, you need to write the object. Okay, so it was like mm, okay, suppose if you take a class example, mm, so class example, I am declaring int a, int b. Okay, and I am writing the function void display. This is my function, and some piece of code I am writing, and next end function and end class. Okay, so here first what you need to do, you need to step 1 you need to create. So I wrote the class. Okay, so for that you need to create the handle for the class. Create the handle for the class. Okay, so I am creating, suppose example ex underscore h. Okay, step 2, instance creation or object creation. Okay, what is step 2? Instance or object creation. Okay, instance creation. So how I am creating instance ex underscore h with this handle I am using new this normal brackets. Okay, and I can give some value for this instance for this object also. Okay, so for this handle ax underscore h equal to what, I can give some value 50. Okay, so like this means class is nothing but when you are writing the class, memory will be not created. So when it will be created, you need to create a handle, and with the help of that handle you need to create the object. So when you are creating the object, then only the memory will be created. So how the memory is created means memory is created dynamically. Is it fine? Shall I move forward?
Yeah.
Okay, so I wrote some programs. I'll explain that programs. One second. Yes, oops. This I will share in the Google Drive. Test 1. Okay, so this is test 1. If you see the test 1, one second. So class test 1, this is class test 1. This is nothing but properties. Int a equal to what, 20, and methods. So in the methods you need to write the function. Okay, function void display. So void is nothing but it will not return anything. Void display dollar display, the value of a is percentage d comma a, end function and end class. Okay, so till here I wrote class. Okay, I wrote class. Okay, after that I need to write the handle. Okay, step 2 is nothing but I need to create a handle. Okay, so module tb test 1. Okay, this is a class. Okay, test 1 is the class. T underscore h, this is the handle. Okay, so t underscore h handle, this is the handle for the class. And next I need to create the object with the help of this handle. So initial begin t underscore h equal to what, new. So this is nothing but creating my instance. Okay, creating my instance. I want to modify that value t underscore that handle t underscore dot h dot a equal to what 30. Okay, t underscore h dot a equal to what 30. So I need to modify the property. Initially what property I gave, int a equal to 20 I gave. I know I want to modify that property. Okay, so I need to modify from 20 to 30. So here how I declare t underscore h dot a equal to what 30. Okay, after that I am calling that method. Okay, how I am calling t underscore h dot this display, this function name is nothing but this is calling. Okay, so this is a basic example of class. First you need to write the class, and next you need to create the handle, and you need to create the object, and you need to modify the property, and next you need to display the display this value. Okay, so this one just I'm executing in the EDA playground. Program is fine now.
Yeah.
Okay, so I'm opening this EDA playground once again. Yes, so see here, so I copied that and I'm running this program. So when I run this, I will get see here the value of a is what initially I declared a into a equal to what 20. This is the property. Okay, after that this is the class. Okay, so this is the class, and in the methods I wrote the function. After that in the I created the handle for the class, and with the help of the handle I'm writing for the object. How you write the object? You create the instance or object t underscore h equal to new, and I'm modifying the property. Initially it is 20, so I'm modifying to 30, and after that I'm displaying this function. Okay, so displaying this function, so that means it will go to here and it will display. Okay, so I can change the value also, it will be displayed. Suppose if I want to change the value to 50, it will be displayed. The value of a is what 50. Value of a is what 50. It's fine now.
Yeah.
Okay, next use next next test 2. Test 2. Okay, test 2. So here what I am giving, here class test 1 reg a method function. So I wrote the function. Okay, I wrote the function function void display dollar display the value of a is what, and this one end function and end class. This is my method. Okay, so in the method I'm writing the function, in the property I'm declaring the data type. Okay, so module tb test, so this is handle for the class. After that I'm creating the instance and I'm displaying. Okay, can you guess what is the output of this code?
Uh, I can't.
Reg a, what is the default value
Ch-
of a reg? In the Verilog we already seen, no default value. Here I not declared reg. Okay, here I not declared reg, just
okay.
I given reg a. Okay, in the Verilog
Mm.
I told the default value for reg and wire. So what is the default value for reg?
It is X.
Yes, exactly.
X. Yeah.
It is x. It will execute x. Okay, if you run this code, one second, I not copied. One second, test 2 no. One second, copy this, just paste this. Where is my test 2 no? Okay, one second, test 1. Okay, no, test 2, test 2. class test2 I need to give test2 run. The value of x a is what? X. Fine, no? The value of a is what? X. Okay. So I not declared
Yeah.
any value. So the default value for x is what? So default value of x is default value of reg is what? X. Okay.
X.
Okay. So that is a second example, and next example we'll see test 3. Test 3. So this is test 3. Here what I need to do here okay. So I created this class test3. So regia I can use bit also. Okay, instead of this bit I can use bit also. I'm using a constructor that is function function new. Okay, I'm using a constructor that is nothing but function new, and a equal to 0 and end function. So this is method. I'm writing the function void display. So display a is percentage d a end function and end class. Okay, and next so I'm making this handle module tb test3 t underscore h. This is character class name. Okay, so the t underscore h is character class name, and I'm creating the instance and I'm displaying. Okay, so this is t underscore h dot display. Okay, this is nothing but call by method. Okay, I'm calling this call by method. So just if I execute this test3, copy and paste this, run this. See, the value of a is what? 0. So that means here I created a new function. Okay, function new, and a equal to 0. Okay, end function. Okay, I created one constructor, and in methods I wrote this function, display function. After that I'm calling this display. So whatever the a value is there, so that will be displayed. Okay, so this is the constructor. Okay, so this is the use of the constructor. Okay, so every class, like there is a constructor. Okay, every class there will be a constructor. Okay, so like suppose one second. So every class there is a constructor. Suppose like if you see so here that example I told you, no, like class test. Okay, class test. Okay, class test, and test t underscore h. Okay, that is equal to what? New I told. Okay, so new. So that means so here what happens when t underscore test t underscore h equal to new means so one memory location will be created here. So this is nothing but handle. So t underscore h, here object is created, and a will be allocated with 20. Okay, a will be allocated with so with 20. Okay, so when it will be created, so that means either in runtime it will be created in the runtime. Okay, it will be created in the runtime. Okay, so what are the uses of classes? So we can so uses of classes. Okay, so uses of classes, you can create the memory. Okay, so by using class you can create the memory. T underscore h, that is equal to what? New. You are creating a memory. Okay, and we can instantiating or we can initializing the variables. Initializing the variables. Okay, initializing the variables. Okay, so these are the main uses of classes. Okay, so classes. Initializing the variables means how we are initializing the variables means, so suppose initializing the variables means class test, okay, and reg a, and this is some piece of code, end class, okay, initial begin, uh, test t underscore h equal to new end and end module. Like this you can initialize the variables, okay, okay. Here like previous one program, null pointer is there. This is one important question in the interview also they will ask. This is null pointer, okay. So previously this program is related to null pointer, okay. So this program, if you see the null pointer, so here what I did, same thing. So a equal to 20, this is property, and this is the function, okay, function data display. So this is the methods, okay, this is function I wrote, and after that I created the handle initial begin. So here are not created, that means here I given with what just comment, okay. So if I execute what so what output we'll get, we'll check, okay. So this one I'm making as a what comment, okay. I'm not creating any instance or object. So what will happen we'll see, okay. So just we'll see in the EDA playground. So I'm copying this, just you paste in the EDA playground. See here, done. One second. You are getting some fatal error, but you will get some runtime error, okay, fatal error, some null pointer access, like that you will get, okay. So that means we are not creating any memory like that, we are getting, okay. One second, I will check null pointer. Just copy this and yeah, here I need to give that class name. So test1, and here also I will give test1 only, okay, not null pointer, test1 I will give, okay. So test1, that should be same, run, okay. If I run this program, see here, so that means here you need to remember, that means it is compiled, but there is a runtime error. What runtime error is you are getting? So runtime, that is fatal error, runtime error. So test bench null pointer access, this is nothing but what? Null pointer access, okay. So when you are compiling this code, you are getting what? Null pointer access. That means object is not created, so memory is not created, and you are getting a fatal error, that is runtime in the null pointer access, okay. So this is one of the interview question, like if you are not creating the object, what is the fatal error, or what is the error you are getting, okay. So when you are not creating the object, okay, what error you are getting? So that means you are getting a that we already seen, no, runtime error, okay. This is nothing but runtime error, okay, or fatal error. What is that error? That is nothing but null pointer, okay. So here when you are so you are getting when you are so you are getting runtime error, or we can getting fatal error, or null pointer access, okay, null pointer access. So that means I can write here, if no instance is created, okay, no instance or object is created, okay, no instance is object is created, is created by the user, okay. Then handle will point to, then you created the handle, but object is not created, okay. So handle will point to where? Handle will point to null pointer, null pointer, okay. Null object, okay. So we can call as this is null object, null pointer and null object, okay, null object, okay. So this is a very very important interview question. They will ask, you can write. So like means you created the handle, but you not created the object, okay. So when you execute that program, so what you are getting, you are getting runtime error or fatal error, that is null pointer access, okay. So when you are compiling, that will compile, but you are getting, that means memory is not created, okay. So this is about the important thing, that is null pointer, okay. So null pointer. And next this is about the, and next if you see base class, okay. So if you see the base class, this is base class, okay. Example I told, example, one second, example, okay, example I will tell you afterwards. Base class, okay, base class 1, I will tell you. This is the base class. File, edit. So if you see the base class, so how we are like this is a base class. So if you see here, so I'm creating a class, that is base class. I'm declaring this int data, okay. This is properties, and next I'm using function new string, okay, no string, and I'm displaying, okay, dollar display called from the percentages instance created, yes, and end function, okay, and end class, okay. So in the class, within the class, I wrote within the class I wrote properties and methods, okay, properties and method. After that I'm writing module top and initial begin, okay. So I'm creating the that handle. What is my handle? Base underscore class b underscore h1 and b underscore h2, okay. So I'm creating the object b underscore h1 equal to new b underscore h1, b underscore h2 equal to new b underscore h2, okay. End and end module, okay. So that means what it will display, we'll see, okay. So this is related to what, strings, okay. This is related to strings, okay. So once you see this, I am running this, okay. When I am running this, you see I am getting compilation error, okay. Syntax error, 1 second. Base class, copy and paste, syntax error, SV 9th, initial begin module tab 9th and 12th. Called from this class, okay. And module, yes, 1 second, this one I will tell you, okay. 1 second. So this one I am copying, getting error, okay. This one I will see and tell you. We will get called from b underscore h1 is instance created, called from b underscore h2 is instance created, we need to get, okay. So where I'm getting error, 1 second, base underscore class, base underscore class, h1 new. Okay, and function, this one I will tell you. Okay, so this is a base class, means base class will be created like this. Okay, so it will execute. So just this I need to see. Okay. Okay, next is example. Okay, if you see the example, this is the example. Okay, so if you see the example, so class example, and I am initializing this int data. So this is the data type. Okay, properties and properties, and I am initializing the function new into val1. Okay, into val1, data equal to val1, and dollar display, the value of data is percentage d comma data, and end function and end class. Okay, so this is nothing but methods. Okay, so for the methods we need to write the function. Okay, after that in the module TB I need to create the handle. What is the handle? So my class name, what is my class name? Example ex underscore h. Okay, this is the handle, and after that initial begin ex underscore h equal to what? New of suppose 10. Okay, so new of 10, and end module. Okay, so that means here when you are calling this new of 10, what happens? The value of data will be what? Val1. So that means val1 will be allocated to this 10. Okay, it like that function by reference, we already seen in the functions, no? So that means reference, that calling by reference, we already seen. Okay, so like that, if you see, so if I execute this, just run this code, so see here, the value of data is what? 10. The value of data is 10. So you can execute. That means you can make some whatever the value in the new function you can give. Okay, so if you run this, okay, if you run this, so it will be execute, the value of data is 50. Okay, so first thing is, first you need to write the class. In the class you need to write the properties. That means you need to declare the data type into whatever the variable, and you need to write the methods. So for in the methods you need to write the function. Okay, function, and after that you need to create the handle, and for that handle you need to create, with the help of this handle you need to create the object. How we are creating the object? Initial begin ex underscore h equal to what? This is the object, new bracket 50. So whatever the value you are writing here, that value will be displayed. It will go here and it will call this function, and it will be displayed like this. It's fine, no?
Yeah.
Okay, next, so conclusion. Okay, what is my conclusion? So I will show the conclusion. Conclusion. So conclusion, new constructor is present in each and every class. You have a new constructor, no? New constructor. Okay, a new constructor is present in each and every class. Okay, and next, you can optionally use new constructor or method inside the class. You can optionally use new constructor or method inside the class. Okay, inside the class. Okay, and next, whenever we are creating the instance using new, whenever we are creating the instance using new instance or object, both are same. Okay, new method, the function which we have written inside the class, the function the function which we have written inside the class class will be called if you have declared if you have declared, okay, if you if you have declared okay. So this is about the conclusion of this and next fourth conclusion is new method can have optional arguments. New, okay, this is new constructor method. It can have the arguments or cannot have the argument, that is the optional, okay. Can have optional arguments, have optional arguments okay, optional arguments. So last program we already seen, that means this program, so that means some new function doesn't have the argument. See here, new function doesn't have the new constructor doesn't have the arguments, but some programs we already seen new function have the arguments. See here, so optional, that arguments, whatever the arguments are there, those are optional only, okay. So these are the conclusions related to the class, okay. And one more program will related to this accounts, okay, accounts. This is accounts, okay. This program, if you see this so like it's like means I want to check the balance, okay. So I'm creating the account, okay, class account C1, and balance is nothing but it's a number, no. So balance is nothing but it's a number. I am initializing with the property data type balance, okay. And in the methods I'm writing, okay, function int summary, okay, return balance and end function, okay. I'm writing this balance, okay. And I'm writing one more task, okay. So what happens, suppose if you want to deposit any cash, okay, so that cash will be added to the balance, no. So cash will be added to the balance means what, so you need to write the task, okay, task to deposit the cash. So task deposit int cash balance equal to what, balance plus cash, okay, and end task and end class, okay. So here I wrote the class, okay. So till here I wrote the class. In the class I wrote the methods by using function to display the balance, and to update the balance when you deposit any cash, I wrote with a task, okay. So this is my class. After that module TB, I need to create one handle. What is that? My handle account, okay, account underscore C1, this is the class. My handle is ACCH, okay, this is my handle. Initial begin, okay. I need to create the object or instance, okay. So how I am creating, ACCH equal to what, new, okay, this is my object, okay, this is my object. I told you, no, for every class there is a object, okay, or instance, okay. After that deposit the cash. So how I am depositing, that means ACCH dot deposit 2000, okay. So depositing the cash, I deposited 2000, and I want to display the balance, dollar display, the balance is percentage d account ACCH dot summary, okay. Summary means what, where it will go, it will go to this function and it will execute this balance, okay, return the balance, okay, it will display balance, okay. So next it will display account balance, the value of balance is percentage d, this is account summary, and this is how I want to display the balance, okay, after updating the after depositing the cash, I want to update this, okay, ACC dot balance, okay. So this one is related to the account, okay. So I want to execute this program, just to copy this and paste in the EDA playground, just run this program. See here, so initially balance is what, balance is 0 only, it will be int 0. So int balance means what, int balance means balance is updated with 0 only. So after means what is the balance, So the balance is what summary. So balance is 2000. The value of balance is what 2000. You are getting balance. Display balance is 2000. Okay. So like this we can display the balance also. Okay. And one more example, account 2 is there. So here we are using the which command means this there is a keyword called this. Okay. This is nothing but we are using for local properties. Okay, this is command. Okay, there is a this command. Okay, so if you see the this command, one second. Okay, there is a this command. Okay, what is this command means? This is a keyword. Okay, in SystemVerilog also you have some keywords. Okay, this. Okay, so this is nothing but keyword. It's a keyword. Okay, so this is used to referring local variables, local properties or methods, okay, properties or methods in the same class scope, the same class scope, okay, class scope. So I can use this dot balance in the task I am writing. Okay, so this dot balance plus cache, okay. So here I'm executing this program. So account 2. Okay, account 2 I opened. Okay, account 2. Okay, see here same thing. So class account c2 into balance. I'm writing the methods, that is by using function into summary, return balance, end function, and I'm using task to display the balance. In the task what I am doing, so this dot balance, dot balance plus cache. Okay, so balance plus cache and end task. Okay. Next in this I'm executing this display. Okay, so displaying the, so here in the TB, so I created the handle. After that I created the instance or object. After that acch dot deposit 2000 dollar display. I want to display the balance, I want to display the value of balance. Okay, so this one, this I can't execute, just to copy this. Okay, and next paste this, run this code. Same balance is what, balance is 2000, and you can use this also. Okay, balance is 2000 and the value of balance is 2000. Okay, so like this. Okay, it's fine now. Classes, objects, instance, handle. What is class, what is object, what is handle.
Yeah.
Okay, just you try this assignment. So tomorrow you show me one assignment I am giving. Assignment, there is a class. Okay, let us take class test. Okay, I am initializing suppose int a equal to what, 20. Okay, int a equal to 20, and you have two handles. Okay, let us take this is handle 1 and you have handle 2. Okay, handle 1 and handle 2. So let us take this handle is what, t underscore h1 sorry t underscore h1, and this is t underscore h2. Okay, t underscore h2. Okay, so this is, so by with the help of this handle you are creating an object, and this also you are creating an object. Okay, you are creating an object. Okay, after that how we are creating the object, t underscore h1 equal to what, new. Okay, and next t underscore h2 equal to what, new. Okay, so like this you are creating an object or instance. Okay, after that what you need to do, you need to copy. Okay, so that means t underscore h2 equal to what? T underscore h1. T underscore h2 equal to what? T underscore h1 means whatever the content of this handle, you need to copy to h1 or h2. Okay, and change the properties of a. Change the properties of a. Okay, so change the properties of a means what? Initially what is a equal to 20, no? So now you change change the properties of a means what? T underscore h2 equal to h2 underscore h2 dot a. Okay, h2 dot a. Okay, dot a equal to, you change that value to 30. Okay, 30. So you need to change the properties of a. Okay, after that you need to display the value. Okay, so you need to display that means $display uh, the value of the value of t underscore h2 dot a is percentage d uh, comma t underscore h2 dot a. Okay, you need to display these values. Okay, and next similarly $display the value of t underscore h1 dot a is percentage d comma t underscore h1 dot a. Okay, did you understood the assignment? Shall I tell one more time?
Yeah, understood.
Understood, no? Okay, okay. So I'm expecting tomorrow. So if you are not getting me, so we'll discuss tomorrow. Okay.
Yeah.
Okay. Okay. So all about this session. One second.
Yes, no doubts. Thank you.